Well, hello friends. Welcome back to the program. Today we are going to work on profiling in Serenity, and I would like to build a signpost marker mechanism. And let me show you what I mean by that. So if we run the JavaScript test suite here and grab a profile of it, and then let me bring that up in the profile application. So when you look at this, it's just a big blob, and you don't really know at a high level what the test suite was doing at what time. So what I would like to build is a way for user space programs such as test.js to emit a profile signpost, which would then show up here in the timeline as a little marker. And the idea being that we can learn about the program's own idea of what it was working on at the time. So I think that could be really cool. So let's try to build it. And we'll start in test.js, I guess, and add, wait, where do we actually run test? Oh, this is in some header now. Run file. Run file test. Yeah, this sounds like the thing. Where do we print out? Okay, well, I guess here is where we start to run some test. Yeah, we set currently running test, so I assume that's a good place to do this. So what we want to do is we want to emit some kind of perf event. And let's call it perf event signpost. And what are the arguments here? We're going to need our header, actually. So perf events can already be emitted, and we do that from malloc and free and some other things. But there's no way to do like an application custom thing. So we only have these hard-coded things. If we go and look at them, these are the ones that we currently support. So I guess we'll just add a new one, actually. Signpost. And perf events is called. Where else do I need to add it? Here. Okay, and then the arguments to perf event itself are the type, so that's going to be perf event signpost, and then you have two arbitrary pointer-sized arguments that you can use to pass anything. And what happens with that is that it ends up in the profile, and then it's up to the profiler to interpret that. So in our case, I think we want to emit something like, we want to emit a file name, and we can't really put a file name into two integers. So maybe what we really need is a way to register a string with the profiling system. So let's also have that. So register string. Or you know what, let's do one thing at a time. First off, let's just log a cool number when we start processing a new test. Let's start with that. So this use of the API should just work. We don't need any fanciness for including strings. And let's see if that builds. Oh, we don't even have serenity.h. because this also builds on Linux or whatever your host system is. So we have to check it like this. Because of course there's no perf event on other platforms. This is just our own mechanism. Okay, so then that should build, and that almost builds. What did I screw up here? Oh. Okay. Now, the profile application has a event mask that it uses. So you can filter which type of events that you want. But I think in the case of signpost events, we just always want those. So let's just add that to the event mask by default. And then we need to look at the kernel. So what is the kernel going to do when he gets a signpost event? And for all the different event types, we have this union here in the kernel performance event structure that depending on the type of event, we store different data about it. So here we'll just add a new signpost performance event. And that will be a struct GNU packed signpost performance event. And I guess we'll just have like arch1 and arch2. We don't need to get fancy. We can just keep those. And then let's see, where do we add these? Where is this used? Here. Okay. So at the end here, we'll just do perf event signpost, event data signpost arch1 is arch1. Cool. And then those are used in here. This is where we're producing the JSON output in the kernel. So same story here, except we will emit add type signpost, add, I guess we can just do arch1, event data signpost arch1. No need to get fancy here. And break. Okay. So I wonder if that's everything we need on the kernel side to emit these. Let's, we'll find out. We'll just try to run test.js and see if it produces a bunch of these events. We'll see. Okay, so profile C test.js. Blah, blah, blah. And we'll take that. Okay, so now we have it here, and we'll grep for signpost in P. And oh, it seems like we have problems with grep. Okay, I didn't foresee that. I guess it's because it's all one big line. Probably grep doesn't handle huge lines like that. All right, so we have our signpost events. That's awesome. So let's see. Actually, let me store that in a file and take a look at it with the text editor just so we can double check. Yeah, those are the arguments that we passed, arch1, arch2, and we even have a stack trace for it. That's pretty cool, actually. So you could even, like if you know that something is interesting and you want to find out about it, you can signpost it, and then you can find it in the profiler later. Because unlike CPU samples, the signposts will always get emitted, right? Because they're explicitly emitted by the user space code itself. So if you want to capture something really interesting, that's kind of cool. Anyway, moving forward. So now we're producing those things. Let's see if we can make them show up in the profile timeline. So where we load the perf core file, we now have to parse the new type. So that's else if event type is I already forgot what I called it, signpost. Okay, so event, let's just say arch1. And arch2. Yeah, ultimately we need to have some way to plumb a string through these. But for now, let's just do numbers first, and then we'll get the string thing later. And let's see. So maybe we should put the we could put the signposts in a separate event stream. Also, we don't need to put them in the regular event stream. So we'll do something like this: signposts. And then we'll pass that into the profile constructor, because then we don't confuse regular samples with signposts. And let's see, event and vector event signpost. Okay. All right. And where do we access these? Like events has an accessor here. Yeah, so let's just do an accessor for those. Signposts, signposts. All right. And then, oh, how do we draw this? So I guess in the timeline track class, we can, how do we paint here? The way that we paint a timeline is that we compute a histogram of all the samples, and that's how we know like if an area of the profile is like hot, because it has a lot of samples in a little range. Then the histogram is how we gather and accumulate that information. And that's what we draw here. And then after that, we draw, if there's a selection, we draw the selection. And I guess we can draw the signposts at the end here. So M profile signposts. And then how do we filter? Oh, I guess like this. So it has to be the right PID, and the process has to be valid for the event serial number. So let's see, something like that. Signpost. And then what do we do then? Then we got to compute, maybe let's just draw it as a line. So the X is going to be the signpost dot timestamp minus the start of the trace. And I'm actually just scanning up here times the column width. So yeah, so actually this thing right here, this logic will just do that, but signpost timestamp. That's our X value, and then if we draw just a line from the top to the bottom, that would be from frame thickness at the top to height minus frame thickness times 2. I think that's okay. And then painter, draw a line from XY1 to XY2. Color magenta, the best debugging color, objectively speaking. And I'm definitely forgetting something here. Yeah, I didn't even add those things. Where did I do that? Arch1 is... Okay, so this is the profiler applications idea of an event. And now I'm adding... This feels kind of crappy actually, but like I'm adding these. But depending on type of event, you're going to have different types of arguments. So we're kind of bloating this data structure where we could really use a union. So put type specific arguments, event type specific arguments in a union to save memory. Yeah, that would be a good idea. But for now, let's just bloat it up so that we can save. And let's see how that goes. The profile constructor. Oh. Needs to take that vector that I added there. Yeah, sure. Signposts. Okay. Wait, do we have everything we need here already? Can we just open that? Or no, that's not. Well, that should have signposts in it, actually. Let's see if we are actually catching these. So in the timeline track, signpost at signpost timestamp, just to see if there are any of these in the file. Okay, well, nothing that we're rendering. Okay, so what did we mess up? Signposts, new profile, copying, and we're moving in the signposts here, sure. And where do we accumulate those? Here, but when it is a signpost, oh, we never added any logic to filter based on that. So that goes here, I guess. Right, we're just unconditionally adding to events. So let's say if it's a signpost, then signposts append, move event. Otherwise, put it into the regular stream. Yeah, I'm hesitant to add more stuff to the regular stream because the regular stream has so much stuff in it. And since we want to iterate over just a signpost here, it seems really like a good idea to have it separately, because otherwise we would have to filter on the event type here as well and go through like potentially tens or hundreds of thousands of events every time you paint, which would be unfortunate. So where do I get is signpost from? I guess I can just say like bool is signpost. And then here we just set that it is a signpost. True. Okay. Now, it has oh, look how many signposts it has. I think that debug logging is probably killing us. Let's see. Let's not do that. Okay. Yeah, debug logging in Serenity is weirdly a performance problem in itself. Okay, so that looks more reasonable. And look at that. So we have a magenta line, presumably every time that we start doing a new test into the JavaScript test runner. Also, we go for quite a while here without starting a new test. So that seems to be like a really long running one. Wonder what it's doing. Well, we are certainly in the right place to find out what it is doing. So let's see. Regular expression matching. Look at that. libregex matcher. Libregex matcher match. Ooh, and we're in the bump allocator calling mmap. Okay. So the regex engine is allocating, and that's expensive, and that's what we're doing here instead of running many tests. This is definitely probably something we could look into. I mean, unless the test is absurdly like memory heavy out of necessity, but oh, what happened there? I lost the track. We have a bug. Let's ignore that. Okay, so now we have the signposts showing up, but how do you know what they mean, right? So let's see. I guess we can, what if you can just hover them and it will tell you? That would be nice. So for that, let's go ahead and implement a mouse move event. And I think I can put that right here. So timeline track, mouse move event. And what are we going to do now? Now we are going to, I guess we have to iterate through the signpost again. Okay, so then we figure out the X value for that signpost, and then start of trace. Oh, these come from, these are locals in the paint event. Start of trace. Okay, well, that's just the first timestamp of the profile. So that one, we don't even need to get fancy with that one. First timestamp, no problem. The column width is oh, I guess it is like the width of each histogram stack or whatever, histogram bucket rather, but it respects the UI scaling. So if you zoom in and out, then it will respond to that. So I think maybe what we should do here is just make well, let's move this to a helper function so that we can call it from many places. Column width, let's say const. Let's put that down here. So float timeline track, column width, shoop-a-doop, and there we are. Beautiful. So now we can call that from here, although I don't want to call it again and again. So let's just say column width is this column width. Also, this this filtering code here is kind of like, we don't need to have two of those, right? So for each signpost, auto signpost. And then we'll just put this filtering somewhere else. That would be a bit nicer. So let's make a templated iteration function for each signpost. Invoke the callback. Boom. Yeah, that's kind of nice. And oh, let's actually even support iteration decisions because why not? If we want to leave, then we leave. Break. Yeah. Okay, I think that actually seems like a super good idea. So let's put that here. Okay. And for each signpost, oh, and then we need to return iteration decision continue. Sure. And we were using that in the paint event also. So let's just, for each signpost, like this. Oh, that becomes so much nicer. Beautiful. Okay. And then now, what do we want to do now? I guess we want to check if you're hovering over a signpost, right? And maybe we should make them a tiny bit fatter just to be nice, because 1 pixel is a bit, it's not very much to hover. So let's maybe make a rect out of this, like a hot rect or whatever. Let's call it the hoverable rect. Starting at X. Let's see, const expert int hover padding. hoverable padding, let's say. I don't know, 2. And we'll start it there. And the width of this should be hoverable padding times 2. Does that make sense? And then the height should just be height minus frame thickness times 2. Yeah. Okay, and then if the hoverable rect, the hoverable honorable rect, why are you complaining? Hoverable is a word, isn't it? Is hoverable a word? Hoverable. It's a word, come on. Capable of being traversed by hovercraft. That's obviously what I mean by hoverable. Sea lion. I mean, the dictionary probably comes from my system, actually. Whoever made the dictionary, come on, hoverable is a real word. If hoverable rect contains the, wait, do we have like, oh, contains horizontally. X. No, event X, of course. Then it's a match. And this is where we should show the tooltip or something. So, well, we should also stop iterating here because we found a match. So let's see. Application the. I know somebody recently added a thing to GUI application for showing a tooltip immediately. So I think we can use that. It's called show tooltip immediately. I forget who added it, but it's a cool thing. Maybe CLion can tell me actually with git blame feature. It was Tobias Christensen. Well, thank you, Tobias, for adding this API. So I want to do that, and I want to show, let's make a string here. So formatted signpost, and then we just put the arguments. So signpost arch1, signpost arch2. What's the second argument? Oh, which widget is generating the tooltip? Me. Okay. What if we don't hit something though? I guess hovered signpost, hovering a signpost. Yeah, we'll just do one of these puppers. So true, and at the exit, if not hovering a signpost, then GUI application hide tooltip. Please call it on the instance, and there we go. Okay. Oh, wait, what am I doing wrong? I forgot to return an iteration decision. Oh, in the paint event, of course. Right, down here. Yeah, so in the paint event, we always iterate through all the signposts. I guess technically we could skip over signposts that end up outside of the current clip rect. But like, that doesn't really matter. At least let's not worry about that until we have evidence that it does matter. Okay, so that's awesome. I can actually see a little bit about them. Of course, they all have the same metadata, but that's so cool. Oh man, okay. So what if this thing would increment every time? So instead of 1 here, it would do like a static count. And then we would just increment that every time so that we get, I just want to see that we can actually show like something different for every signpost. Okay. And look at that. That's so neat. Also, I'm surprised that we only go up to 400 something. Oh, maybe we run out of space in the profile buffer and then it just cuts off at the end. That would be interesting. Oh, it disappeared again. Oh, wait, I bet that's, I bet you that if I zoom in and then I scroll and then I zoom out. Ah, yeah. That's not good. Yeah, because now I can't get back to that thing. Yep, that's definitely a bug that we should fix, but not one that we're here to fix right now. So, ignoring that, let's see. Let's do some commits here because we are accumulating so much code. So let's do the kernel changes first. Just making it possible to create these things, and let's also add the libc constant, and I think that's what we need. Yeah, so kernel plus libc, add perf event signpost. This event will be used by user space programs wanting to mark interesting high-level events in the profile. Okay. Yeah, this is going to be awesome. And then let's do the little profile program, just enabling these by default in profiles, because I think you always want these. Perf event signpost. I think you always want them. I don't know. Maybe I'm wrong about that, but then we can always change the default. Because the profile thingy allows you to like add additional perf events. But I think this makes sense as a default. And then let's see, DevTools profiler. Yeah, so here we're adding parsing of the signposts to the profiler app and also the basic display of them. I think that's good. The hover thing is really nice. The magenta thing is, let's call that temporary maybe. We'll we'll iterate on it probably very soon. But let's see. So profiler, parse, and paint perf signpost. Profile signpost events. Signposts generated by perf events now show up as in profile timelines, and if you hover them, you get a tooltip telling you which tooltip with the two arguments passed along. With the two arguments passed with the event. Yeah. Okay. All right, and then let's see. So I guess I really want to have a string, right? And I feel like this is not really enough. So how do we get a string? Like, what would it look like here at the call side, actually? So the thing I started thinking when we were just beginning was something like this: a perf register string, and then an ID, I guess. So like 1, 2, 3, 4, or whatever, and then whatever the string should be. So test path dot characters test. Let's pass in the length as well. We don't need to accommodate C strings. And then you just emit that. You don't need the count. And then we can say that the first argument to perf event signpost is a string. And then the idea here is that these strings will be remembered per profile. So wait, let's see how we would implement this. But basically, like if you have a string that keeps reoccurring, so if we were in the JavaScript heap garbage collector, right? And you wanted to emit something every time you do a garbage collection, then you could do like perf event signpost. And here you would put some cool number. And that would mean like garbage collection. And then maybe we would have a global GC counter. That would actually be really cool. But in the case here, we don't need to register a new string every time this happens. So this would be registered maybe when we construct the heap. And we would just say like perf register string. And let's see how we would do this actually. GC signpost string. Lib.js GC or garbage collection. Let's say garbage collection. Yeah, that's cool. So GC signpost string characters, GC signpost string length. Also, let's put that into a constant here. GC string ID, perf string ID. String ID is a pretty cool name for that. Okay, so it's string ID, and then I guess all of this needs to go in if def serenity. Yes, if def serenity. Okay, and then once we've registered that string, then it becomes as easy as just passing it like that. Yeah, and then it would emit a signpost with this string that you've already registered. Yeah, this is because in the test runner case, like you're always emitting a new unique string with the current path. So this looks kind of weird, but this is a much more illustrative example of why it's useful, because you can register the string once. So what does the API do though? Like perf register string. Let's say that it's a new system call. Next to perf event. So as perf register string needs big process lock. Let's just say yes, because I don't want to think about the big process lock right now. And perf event. I'll just get a little sibling right here. So that's the string ID. Then we need a, I mean, it's just the user space string pointer. So like that. And we'll put that here and verify the big lock was acquired. Sure. And then events buffer is the current perf events buffer. Because I think if you're not currently recording performance events, so in other words, if you're not currently profiling, then we should just ignore these requests. Yeah, I think that's the best thing to do, because the program doesn't know if it's being profiled, and it shouldn't know that. So it should still be fine to just generate these events. Just that they end up nowhere. So we'll just silently drop the event, or drop the request, rather, I should say. We should probably drop perf events that are recorded or that are explicitly sent if we're not currently profiling. Like here, the fact that we do create a buffer if you're not profiling, that is a bit weird. I'm not sure I like that. I think we should probably stop doing that, because otherwise, now that we insert these signpost events, that's going to generate profile core dumps after anything that emits these events, even if you're not profiling. So yeah, probably need to look at that. Anyway, so event buffer, say register string ID, and the string is going to be something that we extract like this. So try copy k-string from user. We have to name these arguments, of course. So user string length. Oh wait, that's gonna return one of these things. Okay, good. And string or error, release value, boom. You don't need to move that. And then we just need to invent register string, whatever that is. So the performance event buffer, which is sort of like it's like a profile in the kernel. This object is sort of what accumulates all the profile events or the performance events. And now we'll add an API here. So like register string, maybe it returns a k result. Because if it has an allocation failure or something, it's nice to let you know. String ID and non-null own putter to k-string string. Yes. And let's just, I don't feel good about this, but let's just store them in a hash map for now. And then we need to not use a hash map later because it's a bit unreliable with regards to allocation. In that it doesn't handle out-of-memory situations properly. So we need to use something different in the kernel, or make a variant of hash map that can handle allocation problems. But for now, I'm just going to use it out of convenience. We'll call it registered strings, maybe, or why not just strings? Yeah, strings works. Okay, and then let's see how we implement this. So I mean, this is really just a strings set, string ID, move string. And yeah, it can't even signal allocation failure right now because the hash map doesn't tell us. So fix me switch strings to something that can signal allocation failure. And then propagate such failures here. Yes, that's the future good boy project for somebody, probably myself. Okay, and then we need to actually include these strings in the profile that we generate. So that's right here when we build up the JSON. So the profile that the kernel generates is just a JSON stream, and it is a JSON object at the top level and has an events array, but I think before that we can just put a strings array. Or I guess since it's keyed with string IDs, it should be an object. So we'll do this. That, let's see. Strings, and then strings add. Add, what do we add? Oh, we have to make a string for the key. Oh, this is a bit gross, because I don't like using the ACK string in the kernel, because it struggles to report allocation failure. But there's no more convenient API here at the moment, so I'm kind of stuck. But let's not get stuck. So like that, and then for the value, that's just our case string, so we get his view like that. And I think the scope here will just clean that up automatically, so let's see if that would work. Also, we need to actually parse these in load from perf core. So let's see. Let's parse out the strings first. So hash map flat putter string ID to string. And then object get putter to strings as object. Or maybe we should be a bit better about this. Yeah, let's be responsible here and handle in malformed profiles. Otherwise, we'll just assert. So malformed profile strings is not an object. String. Okay. And then no, wait, how did we get to it? Strings value as object for each member. Cool. Then the key is going to be a string const key. And then we'll have a JSON value const value. Sure. Maybe call it profile strings. Okay, and then flat putter auto string ID is, now we have to do string to int conversion here. That's a bit gross, but it's okay. String ID value. Okay, and then let's just verify that the string ID was indeed an integer. And profile strings set string ID value to string. Okay. So now we have accumulated all of those. We'll get back to you in just a moment. Or maybe, no, let me get back to that in a moment, because I'm on a roll here. So let's keep it going. Let's see. So when we're doing the signposts, instead of just storing arg1 like this, let's say that it's a signpost string. Okay, and then arg1, we replace that with a signpost string. Okay, and then the string ID is now that, and then we'll get it from the profile strings, get string ID value or fallback, which would be something like this. So like signpost, just put the number actually. Yeah, I mean, if we don't have that string registered, we'll just give you the string ID, and maybe you can try to make sense of it. Okay, and then what do we do with that? So signpost arch1 here. This is now just a string. So signpost string. Okay, I think that's what we needed there. And then let's figure out what was wrong in the JavaScript heap. It's probably that I just forgot to include serenity.h. That's my bad. Also, why don't you have set jump? Not found. Okay, well, don't know what to tell you about that. Perf register string was not declared. Oh, shoot. Yeah, of course. We need to make a wrapper for it. Right here. So perf register string uint property string ID string and string length. No problem. And then we'll just do a little copy pasta. Okay. Oh, global GC counter. Maybe I didn't define that anywhere. I was just dreaming it up. Global GC counter. Yeah, that doesn't actually exist. Okay, fine. Let's just, I mean, we can just put it here. No big deal. Okay, so moment of truth. Let's see. Let's delete old profiles and then profile test.js. Also, I realized that the way I'm using that API is clearly not correct because I'm replacing the existing string over and over. I need to do something smarter here. I need to keep a running index or something like that. String ID. So let's see. Perf string ID is going to be starting at, we'll start it there, and then we'll just increment it every time. Yeah, this is what we'll do. I was not really using my brain there. But it's funny when you're building something like this, like many different parts in parallel, and then it's so easy to miss some little detail, and then just you start to assume that you took care of it, but you didn't. Look at all those Oh, look at that! We got the test names. Oh, that's so freaking cool. Oh, and you can even see the garbage collections. Garbage collection 0. Garbage collection 23. Okay, that's so awesome. Now I almost wish that there would be a list of all the signposts so you could see them. And then like you could click on them to jump to them. Actually, we could probably do that, but I'm not going to do that in this video. But that would make a nice tab to have here, signpost. Oh, dude, this is so cool. Oh, I love it. because now we can figure out what test, because right here is that regex range, right? The one that was spending all the time in regex. Regex matcher, sure. And then we can see what test is that. Regex.prototype.exec is the test. Very, very cool. Dude, this is so rad. I'm so excited because I'm going to use this so much. Anyway, let's see. So let's commit. Let's do the kernel changes for the string registration. So perf register string, blah, 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 blah. Just adding that syscall and also to libc, I guess. Yeah, just a wrapper for it. Okay. Sys perf register string. This syscall allows user space to register a keyed string that appears in a new strings JSON object in profile output. This will be used to to add custom strings to signpost event, to signpost, yeah. There we go. And then the profiler changes. So just parsing the strings and then interpreting the arch1 to signpost as a string ID. Very cool. Profiler, parse the strings JSON object. And parse and paint, let's say, parse and render signpost strings. The first perf event argument to a perf event signpost is now interpreted as a string ID. In the profile strings set. This allows us to generate signposts with custom strings. This is so cool. I love this. Okay, and then let's finally add the garbage collection signpost. So libjs, emit a profile. Oh, shoot. libjs, emit a profile signpost. When entering the garbage collector, when starting a garbage collection. Super cool. And the test runner, I'm not super proud of the way that code looks actually. It looks kind of weird. But again, it's probably okay. The thing that I don't love about this is that the strings are global. So maybe that is actually stupid. And why did I do it this way? Like, why didn't I make the API just give you a string ID? That would have been much smarter. Like, why do you have to use constants? Yeah, let's backtrack on that. Let's just register string and then it gives you the ID. What was I thinking? Yeah, that's clearly better. Okay, so let's make it do that. Okay. So we don't do that, but it will give you back the string ID. And then we have a reason to return something. That's so nice. Register string. String ID comes back to you, my friend. And now the string ID becomes an int, but I guess that's okay. That really doesn't matter. String or error. Or, well, hold on. So here we do result is error. Oh, no, wait. I want to keep that result, actually. Return result value. Yes. Although if I did this, then I wouldn't have to do that. So that's also an option. Yeah, let's do that. That's nicer. Okay. And then here we have to flat putter. I guess we'll just keep a counter. Oh, it's not a big deal. Flat putter. Int m next string ID. Yeah. This is going to be so much better. What was I thinking? Seriously. And then here, if string ID becomes 0 because we wrap around, let's say, I was going to say e overflow. I mean, it's not really overflow. It's more like eno mem or eno buffs. Let's say we don't have space for more strings, bruh. Yeah, let's say that. That feels really sensible. And then return the string ID. We still need to change it to a hash map though, so the fix me stays. Right, okay, that's good. And then this constant here stops being a constant, starts being a static int. And we do that. That's fine. It's very cool. Okay, and then we don't need to do this dumb stuff here. That was so awkward, Vote. What were you thinking, Andreas? How did that seem like a good API? I'm probably forgetting about something, but this seems much better. I guess since these are now sequential, we could just use an array instead of an object, actually. This guy right here can just be an array. And strings doesn't need to be a hash map in the first place. Ooh! Wow, the pieces are just... Oh, everything is just getting so much better so easily here. Okay. Add array, and then just add the thing, of course. So obvious. Obviously. Yes, and then we need to take care of that when we profile. When we load the profile, rather. So this is going to be an array. And then as array for each, I think JSON value, const value, sure, string ID. Oh shoot, we still need to keep track of the strings value as array size. Dot at I. And then we can rename that to string ID. Boom. Look at all this simplification. It's glorious. Then we don't need the mnext string ID thing. Strings simply append. String ID is mstrings size. Yep. And then we can just try append here. And then if that fails, then that's our error. Return enobufs. Oh, just look at it improving. That's so good. Okay. Who was calling this? This guy right here. You had too many parentheses. I am so happy that I thought of this change now, because it's such a good and such an obvious change. And I'm sure that 10 people would have commented suggesting the change. So if you already commented this while watching the first part of the video, then good job. Let's see. What's wrong with that? Oh, it's because it's just a regular for loop now. And there we are. And will it blend? I wonder. Okay, so let's get ourselves one of them profiles. And then copy that here. Take a looky-loo. And this is beautiful. It just works. Except now we don't have those goofy hard-coded string IDs. So much better. So let's commit those. Right, so we have to update that everywhere at the same time. Kernel. This is perf register string. Generate the string IDs. Making user space provide a global string ID was silly. And extremely difficult, and made the API extremely difficult to use correctly in a global profiling context. Instead, simply make string registration make the kernel do the string ID allocation for us. This also allows us to convert the string storage to a vector in the kernel and an array in the profile JSON. JSON profile data. Yeah, so that's just like win, 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 win. Win all the way. Very cool. Very, very cool. Okay, and then let's also do the JavaScript test runner thing. So emit a signpost for every test. libtest. Emit a profile signpost when starting at the start of each test. This makes it super easy to see which test is which when browsing a profile of the test runner. That's so freaking cool. Like, I love this feature so much already, and I have a lot of ideas for how we can improve it even further, but damn, this is so cool. Add values to primitive. Look at that going on right there. Who else takes a long time? That's regex. Super interesting. String prototype replace. Okay, well, I think that's going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out, and I hope that you saw something interesting here today. I certainly had a very good time hacking on this. I'm very happy with the feature, and I think this is going to be immensely useful. So thank you very much for hanging out, and I will see you next time. Bye.